So, what if I told you that the secret behind some of the most advanced AI we have today isn't from some high-tech lab, but from an ancient math text? Okay, let's try something. Imagine you have to solve a pretty tricky equation, one with squared numbers and variables. But here's the twist. You can't use any symbols. No x, no plus sign, not even an equal sign. Everything has to be done just with words. How would you even start? Well, believe it or not, centuries ago, mathematicians did exactly that. They'd describe their problems with phrases like squares plus roots equals numbers. Sounds kind of cryptic, right? But this simple word-based puzzle, it actually holds the key to a super powerful technique, one we literally use every single day. All right, so that brings us to our first section, an ancient algebraic puzzle. Let's dive in and crack the code on this old school method. So let's take one of their puzzles and just translate it into our modern language. They might have said something like, a square and 10 of its roots are equal to 39. For us, that's just x squared plus 10x equals 39. Simple enough. But again, how on earth did they solve it without our symbols? They had this really elegant step-by-step recipe. It's actually pretty cool. First, you take half of the roots. That's just the number next to x. So for us, half of 10 is 5. Easy. Step 2, you square that number, which gets you 25. Then you add that 25 to both sides of the original equation. And for the final steps, you take the square root of the new total and then just subtract that first number you found, the 5. And that's it, you've got your answer. And when you follow that ancient recipe, boom, you get the answer. X equals 3. It just works perfectly. But the really fascinating part isn't just that it works, it's why it works. The geometric logic behind this whole thing is, well, it's pure genius. Okay, so that leads us perfectly into our next section, the geometric secret. This is where we get to see the beautiful visual reason behind this algebraic trick and finally understand why it has that famous name, completing the square. The brilliant thing is, completing the square isn't a metaphor. It's literal. The whole point of the process is to take any messy-looking quadratic equation and just rearrange it algebraically until it makes a perfect symmetrical square. It's all about finding simplicity and balance in the middle of all that chaos. And this visual really shows the transformation perfectly. See, we start with this incomplete shape, which is basically the expression x squared plus bx. The whole algorithm, all those steps we just did, is designed to turn it into that elegant, perfect square on the right. X plus b over 2 squared. You're literally filling in the missing piece of the puzzle to make it whole. And this illustrates something so deep and cool about geometry. When you graph these equations, you get those U-shaped curves, right? Parabolas? Well, what completing the square proves is that every single parabola, no matter how wild or complicated it looks, is really just a simple, perfect square that's been shifted around on the graph. It's a pretty mind-blowing way to think about these shapes. Okay, so it's a neat history trick, right? But why should we care about it today? Well, this is where it gets really interesting. This brings us to the big reveal, the AI connection. We're about to see how this centuries-old method is actually at the heart of our most advanced technology. It turns out this technique is, well, it's everywhere. It's the mathematical engine behind things like Gaussian distributions in stats and least squares regression in data analysis. But it goes deeper. It's fundamental to how machine learning models optimize themselves, how neural networks are built, and even how those incredible AI diffusion models generate images. It's hiding in plain sight. And this is the core idea, the big connection. Ancient algebra used this trick to turn a complex equation into a simple, shifted square. Modern AI? It does the exact same thing, just with data. It takes raw, messy, chaotic data and transforms it by normalizing it or centering it, which is just a fancy way of saying it shifts the data so it can find the hidden patterns more easily. It's the same fundamental idea. Shift your problem to find a simpler truth. Which really brings us to our final big takeaway, one timeless idea, and that's the power of a perfect shift. So here's the bottom line. Completing the square isn't just some dusty trick from an old textbook. It is a foundational concept. The idea that you can solve a really complex problem by strategically shifting it into a simpler, more perfect form, that is the bedrock of algebra. And as we've just seen, it's also the bedrock of modern optimization and artificial intelligence. And that leaves us with a pretty fascinating question to chew on. If this one single elegant algorithm, born in a time before they even had symbols, is still powering our future, you gotta wonder, what other ancient ideas are hiding in the tech we use every single day, just waiting for us to notice?